The Monty Hall problem is a brain teaser in the form of a probability puzzle. It's loosely based on the TV game show Let's Make a Deal, and named after its original host, Monty Hall. It's also featured in the movie 21 starring Kevin Spacey, Jim Sturgess. It's a good movie and I recommend you to check it out. It's one of those questions asked very often at interviews. Supposedly it's a good problem to evade the candidate's understanding of probability theory. But the reality is, it's more of a brain teaser, less of a probability question, and many veterans in the industry actually don't feel this kind of question is very telling of candidates' competency. But that's a topic for another day. Here, I'll try to explain the Monty Hall problem with a hopefully fresh perspective, different from what you can get somewhere else. There are many versions of Monty Hall problem. We'll stick to one simple setup. Assuming there's 3 boxes, 2 are empty, and 1 has $1 million in it. You randomly pick 1 out of the 3. Next, the host removes 1 of the rest 2 that he knows does not contain the money. The question is, you are given a chance to switch your choice from the one you picked originally to the remaining one. And should you do it? Many people think there's no difference whether or not to switch because they think the probabilities of both boxes containing the money are equal, 50-50. At the first thought, that seems to make sense. You have 2 boxes, one of them has it and the other doesn't, and each one has the same probability as the other, so why should I switch? If you were ever asked this question before, you must have learned that the answer is you should, and the probability of the other box containing the money is 2/3, not 1/3, which is twice as high as the one you picked at the beginning. The standard answer usually says, oh, the reason is that the other 2 boxes together have a total 2/3 probability containing the money. Since the host removes 1 of them, the remaining box gets the total probability, which is that 2/3. That's really confusing to many people. Some PhDs even read long papers to dispute that answer. We may find it easier to understand if we break down the problem as it is, which is really a dynamic problem. The key here is in the middle of the problem, the premises of the whole problem are changed due to the knowledge and the behavior of the host. Remember, the host knows exactly which box has the money. If he doesn't know and randomly removes 1 of the remaining 2, then it's a completely different problem. Let's break down the problem in sequence. We're going to assume box 3 has the money, but it really doesn't matter. This is just for the convenience of demonstration. There are 3 steps in this problem. Step 1. You randomly pick 1 box. In this step, you have equal probability to pick either of them, which is 1/3. And we need to analyze each of the 3 scenarios in the following steps. In step 2, the host will remove 1 of the remaining 2 that does not contain the money. So, if you picked box 1, the host will remove box 2. If you picked box 2, the host will remove box 1. In either case, they will not remove box 3, which has the money in it. While if you picked box 3, then the host will remove either 1 or 2 since it doesn't really matter. Now, hopefully it's clear. The 3 scenarios have equal 1/3 probability. In step 3, if you switch in 2 out of 3 scenarios, you will get the money. Only in the last one where you originally picked the money box, you would lose it. So you should switch because that's only 1 out of 3. So you have 2/3 probability to get the money box if you switch, while only risking 1/3 probability of losing it. The reason why I consider this a brain teaser but not a very good interview question is that the host's knowledge and behavior changed the problem midway. That changes the premises of the whole problem and it just adds a layer of confusion to trip up people. Imagine the host does not know which box has the money and he just randomly removes one of the remaining two. Should you switch in that case? Obviously, there's no difference whether or not you switch, because the one the host removes may be the one with the money, and the remaining two have the same 1/3 probability of clearing the money anyway. There is another way to think about this problem, which is to use extreme scenario analysis, just like in physics. Instead of 3 boxes, imagine there's 1,000,000 boxes. You randomly pick one of them, just like before in the case of 3 boxes. Then, in step 2, the host removes 999,998 out of the remaining 999,999 boxes that he knows do not contain the money. So he keeps just one out of 999,999 boxes that does have the money in it. Of course, there's a remote 1 out of 1,000,000th probability. You picked the one with the money already, so the only one he left on the table doesn't have the money either, just like the 999,998 boxes he removed. And now in step 3, you are given a chance to switch from the one you randomly picked originally to the one he intentionally left on the table. Should you switch? The answer hopefully is very obvious to you. Okay, I hope you find this helpful. Thanks for watching.